Question 1. What is the angle between the vectors 7, 1 and -1, 1? The dot product relates the magnitude of the vectors with the non-reflex angle between them, theta. Let vector A equal 7, 1 and vector B equal -1, 1. Then the dot product of vectors A and B is equal to the magnitude of vector A times the magnitude of vector B times cos theta. Now the dot product of vectors A and B is given by x1 times x2 plus y1 times y2, so that's 7 times -1 plus 1 times 1 is equal to the magnitude of vector A, so by Pythagoras theorem that's the square root of 7 squared plus 1 squared, times the magnitude of vector B, which is the square root of -1 squared plus 1 squared, times cos theta. Simplifying the equation, we have -6 is equal to square root of 50 times square root of 2 times cos theta, which becomes -6 equals the square root of 100 times cos theta. And square root of 100 is equal to 10, so the equation simplifies further to -6 equals 10 times cos theta. Dividing both sides of the equation by 10 and making cos theta the subject, we have cos theta is equal to -0.6. Taking the inverse cos of both sides to make theta the subject, we get theta is equal to inverse cos of -0.6. Therefore, the answer is option D. Question 2. The diagram shows a grid of equally spaced lines. The vector OH equals H and the vector OA equals A. The point P is halfway between B and C. Which expression represents the vector OP? Diagrammatically, it can be shown that vector OP is equal to vector OX plus vector XP, where X is a point halfway between point G and point H. Algebraically, vector OP is equal to vector OX plus vector XP, which equals 3/4 of vector OH plus vector OA, since vector OA is equal to vector XP. Using the lowercase vector notation, that equals 3/4 of vector H plus vector A. Therefore, the answer is option D. Question 3. Given that cos theta minus 2 sin theta plus 2 equals 0, which of the following shows two possible values for tan theta over 2? Use t formulae to express the terms involving cos theta and sin theta in terms of t, where t is equal to tan theta over 2. Recall cos theta is equal to 1 minus t squared over 1 plus t squared, and sin theta is equal to 2t over 1 plus t squared. Hence the equation cos theta minus 2 sin theta plus 2 equals 0 can be expressed in terms of t as 1 minus t squared over 1 plus t squared minus 2 times 2t over 1 plus t squared plus 2 equals 0. Expanding the brackets here, we get 1 minus t squared over 1 plus t squared minus 4t over 1 plus t squared plus 2 equals 0. Multiplying all terms by the denominator 1 plus t squared, hence eliminating the denominator, the equation becomes 1 minus t squared minus 4t plus 2 times 1 plus t squared equals 0. Expanding the brackets, we get 1 minus t squared minus 4t plus 2t squared equals 0. Combining the like terms, the left-hand side becomes t squared minus 4t plus 3 equals 0. Notice that we have a monic quadratic on the left-hand side, and that factorizes to t minus 3 in brackets times t minus 1 in brackets equals 0, hence t equals 1 or 3. Therefore, the answer is option D. Question 4. What is the derivative of inverse tan of x over 2? Recall that if y is equal to inverse tan of f of x, then by the chain rule, dy dx is equal to 1 over 1 plus f of x all squared multiplied by the derivative of f of x, which is f dash of x. So dy dx is equal to f dash of x over 1 plus f of x all squared. Given y is equal to inverse tan of x over 2, then dy dx is equal to 1 over 1 plus x squared over 4, that's the square of x over 2, multiplied by the derivative of x over 2, which is half. Multiplying all the terms in the fraction by 4 to eliminate the denominator of 4, that equals 4 over 4 plus x squared multiplied by half. And 4 multiplied by half is 2, so 4 over 4 plus x squared multiplied by half is equal to 2 over 4 plus x squared. Therefore, the answer is option C. Question 5. The slope field for a first-order differential equation is shown. Which of the following could be the differential equation represented? It can be observed on the slope field that if the tangent line lies anywhere on the x-axis or on the y-axis, so in other words, when y equals 0 and or when x equals 0, the gradient of the tangent line equals 0. In other words, the tangents anywhere on the x-axis or the y-axis or the origin is horizontal. And that's indicated by the highlighted axes. And this implies that the answer could either be C or D, since the derivative is defined for x equals 0 and or y equals 0. So we can't have x or y in the denominators of the differential equations. The next step is to consider a tangent in any of the quadrants. I'm going to choose quadrant 1. And I've highlighted a tangent in green. And we can see that when x is positive and y is positive, the gradient of the tangent is negative. Therefore, the answer is option D. Question 6. Let P of x equal qx cubed plus rx squared plus rx plus q, where q and r are constants, where q does not equal 0. One of the zeros of P of x is negative 1. Given that alpha is a zero of P of x, where alpha does not equal negative 1, which of the following is also a zero? Consider the sum of the roots 3 at a time. That is, alpha times beta times gamma is equal to negative d over a. We'll call this equation number 1. Now it is given that one of the roots is negative 1, so let gamma equal negative 1. Now a equals q, which corresponds to the coefficient of x cubed, and d equals q, which is the constant term of the polynomial. So from equation number 1, substituting what we know, alpha times beta times negative 1 is equal to negative q over q. Now q over q, of course, is 1. Dividing both sides of the equation by negative 1, we obtain alpha times beta is equal to 1. And making beta the subject, we have beta is equal to 1 over alpha. Therefore, the answer is option C. Question 7. Each of the students in an athletics team is randomly allocated their own locker from a row of 100 lockers. What is the smallest number of students in the team that guarantees that 2 students are allocated consecutive lockers? By the pigeonhole principle, if there are 100 lockers and 50 students, the lockers could be allocated such that every second locker is empty. Hence, there is no guarantee that 2 consecutive lockers are allocated to students. For example, every odd-numbered locker could be allocated to a student and all even-numbered lockers are empty or unallocated as depicted in the diagram. The 51st student must be allocated an even-numbered locker, which will guarantee at least 2 students are allocated consecutive lockers. Therefore, the answer is option D. Question 8. A team of 11 students is to be chosen from a group of 18 students. Among the 18 students are 3 students who are left-handed. What is the number of possible teams containing at least 1 student who is left-handed? The total number of arrangements of 11 students chosen from 18 students, irrespective of whether they're left-handed or not, is 18 choose 11, since order is not important. If the order of the arrangement is important, it would be a permutation rather than a combination. Now take note that the 18 choose 11 includes arrangements which have no students that are left-handed. Now the complement of at least one student is left-handed is no student is left-handed, and that needs to be removed from the 18 choose 11 we worked out earlier. Hence the number of arrangements of 11 students where none are left-handed is 15 choose 11. So if we take out the 3 students that are left-handed from the group of 18, we have 15 students to choose from. So the number of arrangements where no students are left-handed is 15 choose 11. Now the total number of arrangements where at least one student is left-handed is given by 18 choose 11 minus 15 choose 11, which equals 30,459 arrangements. Therefore, the answer is option B. Question 9. A stone drops into a pond, creating a circular ripple. The radius of the ripple increases from 0 centimeters at a constant rate of 5 centimeters per second. At what rate is the area enclosed within the ripple increasing when the radius is 15 centimeters? This is an application of related rates of change. So by the chain rule, the rate of change of the area of the ripple with respect to time is equal to the rate of change of the area of the ripple with respect to the radius of the circle multiplied by the rate of change of the radius with respect to time. So we'll call that equation number 1. Now the area of the circle is given by the formula A equals pi r squared. So dA dr is the derivative of pi r squared with respect to r, which equals 2 pi r. Now dr dt, which is the rate of change of radius with respect to time, is given as 5 centimeters per second. We want to find the value of dA dt when r is equal to 15 centimeters. So from equation number 1, we have dA dt is equal to 2 pi r, where r is 15, so it's 2 pi times 15 multiplied by dr dt, which is equal to 5, and that equals 150 pi square centimeters per second. Therefore, the answer is option C. Question 10. The graph of the function y equals inverse sine of x minus 4 is transformed by being dilated horizontally with a scale factor of 2 and then translated to the right by 1. What is the equation of the transformed graph? Dilate the graph of the function horizontally by a scale factor of 2 by dividing the x variable by 2. So y equals inverse sine of x minus 4 becomes y equals inverse sine of x over 2 minus 4. The next step is to factorize out half from x over 2 and negative 4 so that x becomes monic. So y is equal to inverse sine of half times x minus 8. Next, translate the graph to the right by 1 unit by subtracting 1 from x minus 8. And because x is monic, it makes that process a lot simpler. So y is equal to inverse sine of half times x minus 8 becomes y equals inverse sine of half times x minus 8 minus 1. Simplifying what's in the inner brackets, y is equal to inverse sine of half times x minus 9, which equals inverse sine of x minus 9 all over 2. Therefore, the answer is option A. Question 11a. A particle is fired from the origin O with initial velocity 18 meters per second at an angle of 60 degrees to the horizontal. The equations of motion are d squared x dt squared equals 0 and d squared y dt squared equals negative 10. Part 1. Show that x equals 9t. It is given that the horizontal acceleration with respect to time, d squared x dt squared, or x dot dot, is equal to 0. Now the horizontal velocity with respect to time, x dot, is equal to the integral of the acceleration with respect to time plus the initial horizontal velocity. And that equals the integral of 0 dt plus 18 cos 60 degrees. And we can get 18 cos 60 degrees by resolving the initial velocity of 18 meters per second in the horizontal direction by drawing a right angled triangle and using regular right angled trigonometry. And the integral of 0 dt, of course, is 0, and 18 cos 60 degrees is equal to 9. Now the displacement x is equal to the integral of x dot, or the horizontal velocity with respect to time, plus the initial displacement. Now the initial displacement is 0 because we're starting at the origin. And the integral of 9 dt is just 9t. Therefore, x equals 9t as required. Part 2. Show that y equals 9 times the square root of 3t minus 5t squared. It is given that the vertical acceleration with respect to time, d squared y dt squared, or y dot dot, is equal to negative 10. Now the vertical velocity with respect to time is equal to the integral of the acceleration with respect to time plus the initial vertical velocity. And that equals the integral of negative 10 dt plus 18 times sine 60 degrees, which equals 9 root 3 minus 10t. Now the displacement of the particle in the vertical direction with respect to time is equal to the integral of the vertical velocity with respect to time plus the initial vertical displacement. Now the initial vertical displacement is 0 because the particle is starting from the origin. So y is equal to the integral of 9 root 3 minus 10t dt plus 0, which equals 9 root 3 times t minus 5t squared as required. Part 3. Hence find the Cartesian equation for the trajectory of the particle. The equations of the horizontal displacement of the particle x and the vertical displacement of the particle y are both expressed in terms of the time parameter t. From part 1, we have x is equal to 9t, and I'll call that equation number 1. And from part 2, we have y is equal to 9 root 3 times t minus 5t squared, and I've called that equation number 2. Express y in terms of x by eliminating the time parameter t. From equation number 1, t is equal to x over 9. And we get that by dividing both sides of equation number 1 by 9. From equation number 2, we're going to substitute x over 9 for t in both of these terms. So y is equal to 9 root 3 times x over 9 minus 5 times x over 9 squared. Expanding the brackets, we have y is equal to root 3 times x minus 5x squared over 81, which is the Cartesian equation of the trajectory. Question 11b. A function f of x is given by x squared plus 4x plus 7. Part 1. Explain why the domain of the function f of x must be restricted if f of x is to have an inverse function. For the function f of x to have an inverse function, f of x must be a one-to-one relationship. Geometrically, the graph of y equals f of x must pass the horizontal line test if f of x is to have an inverse function. Now, f of x equals x squared plus 4x plus 7 represents a many-to-one relationship, as the graph of y equals f of x is a concave up parabola. Hence, the domain must be restricted for an inverse function to exist. Part 2. Give the equation for f inverse of x if the domain of f of x is restricted to x greater than or equal to negative 2. Swap the x and y variables in the function y equals x squared plus 4x plus 7 and make y the subject. So swapping the variables around, we have x is equal to y squared plus 4y plus 7. Swapping both sides of the equation around so that the y variables are all on the left-hand side, we have y squared plus 4y plus 7 is equal to x. Subtracting 3 from both sides of the equation so we end up with a perfect square on the left-hand side, we have y squared plus 4y plus 4 is equal to x minus 3. Factorising the left-hand side, we have y plus 2 all squared is equal to x minus 3. Taking the square root of both sides, we get y plus 2 is equal to plus or minus the square root of x minus 3. Subtracting 2 from both sides of the equation so that y is the subject, y is equal to negative 2 plus or minus the square root of x minus 3. Now note that the domain of f of x is greater than or equal to negative 2, as this is the restriction that's been given in the question, which implies that the range of f inverse of x is y is greater than or equal to negative 2. Therefore, f inverse of x is equal to negative 2 plus the square root of x minus 3. Part 3. State the domain and range of f inverse of x, given the restriction in Part 2. The domain of f of x is greater than or equal to -2, which corresponds to the restriction given in Part 2. Hence, the range of f inverse of x is y is greater than or equal to -2. From Part 2, f inverse of x is equal to -2 plus the square root of x minus 3. F inverse of x is defined for x minus 3 greater than or equal to 0, as we can't have a negative value inside the surd. Hence, the domain of f inverse of x is greater than or equal to 3. Part 4. Sketch the curve y equals f inverse of x. The graph of y equals f inverse of x is a monotonic increasing function starting at the point 3, -2. To find the x-intercept, solve for x the equation -2 plus the square root of x minus 3 is equal to 0. Adding 2 to both sides of the equation, we have the square root of x minus 3 is equal to 2. Squaring both sides, we get x minus 3 is equal to 4. Finally, adding 3 to both sides of the equation to make x the subject, we get x is equal to 7. The following is a sketch of the curve y equals f inverse of x, where f inverse of x is equal to -2 plus the square root of x minus 3. Starting from the point 3, -2, and note that it's a closed circle because that point is included in the graph, passing through an x-intercept of 7. Question 11c. The trajectories of particles in a fluid are described by the differential equation dy dx is equal to 1/4 times y minus 2 times y minus x. The slope field for the differential equation is sketched below. Part 1. Identify any solutions of the form y equals k, where k is a constant. The graph of y equals k is a horizontal line with gradient 0. It can be observed on the slope field that y equals 2 is one such solution. The gradient is 0, and the gradient of all the tangents that are on the line are also equal to 0. Therefore, y equals 2 is a solution. Part 2. Draw a sketch of the trajectory of a particle in the fluid which passes through the point -3, 1 and describe the trajectory as x approaches plus or minus infinity. Here is a sketch of the trajectory of the particle passing through the point -3, 1. As the curve is sketched, try to keep the gradient of the curve as much as possible parallel to the adjacent tangent lines. In terms of describing the behavior of the particle as x approaches plus or minus infinity, it can be observed that the y-coordinate of the particle approaches 2 from below as x approaches plus or minus infinity. Question 12a. A recent census showed that 20% of the adults in a city eat out regularly. Part 1. A survey of 100 adults in this city is to be conducted to find the proportion who eat out regularly. Show that the mean and standard deviation for the distribution of sample proportions of such surveys are 0.2 and 0.04 respectively. The mean or the expected value of the sample proportion p hat is equal to p, where p represents the proportion of the population that eat out regularly. Hence, the expected value of p hat is equal to 20% or 0.2. The variance of the sample proportion p hat is equal to pq over n, where p is equal to 0.2, q is equal to 1 minus p, which is 0.8, and n is equal to 100, which represents the number of people in the sample. So the variance is equal to 0.2 times 0.8 over 100, which equals 0.0016. Now the standard deviation of the sample proportion is equal to the square root of the variance of the sample proportion, so that's equal to the square root of 0.0016, which equals 0.04. Part 2. Use the extract shown from a table giving values of the probability that the random variable z is less than z, where z has a standard normal distribution, to estimate the probability that a survey of 100 adults will find that at most 15 of those surveyed eat out regularly. "15 people who eat out regularly out of a sample size of 100 corresponds to a sample proportion of 0.15. Now the z-score corresponding to 0.15 is given by z equals 0.15 minus 0.2 over 0.04. And this is from the z-score formula. So 0.2 corresponds to the mean and 0.04 corresponds to the standard deviation of the sample proportion. Now the probability that z is less than negative 1.25 is equal to 1 minus the probability that z is less than positive 1.25. And that equals 1 minus 0.8944 using the table. And that equals 0.1056 or 10.56%. Now note that the probability that z is less than negative 1.25 is equal to the probability that z is greater than 1.25 due to the symmetry or the symmetrical nature of the normal distribution. Hence, the probability that z is less than negative 1.25 is equal to the probability that z is greater than 1.25, which equals 1 minus the probability that z is less than 1.25. Question 12b. A force described by the vector F equals 2, newtons is applied to an object lying on a line L which is parallel to the vector 3, 4. Part 1. Find the component of the force F in the direction of the line L. The component of the force vector F, or OF as shown on the diagram, in the direction of line L, shown here as vector L, is the projection of OF onto L. Now vector OA is the projection of vector OF onto L and is a scaled version of L. Now vector OA is equal to the dot product of vector OF and L over the dot product of L with itself multiplied by the vector L, where vector OF is 2, 1 and vector L is 3, 4. And that equals 2 times 3 plus 1 times 4 over 3 squared plus 4 squared multiplied by 3, 4. And that equals 2 over 5 times 3, 4. Therefore, vector OA, which represents the component of the force F in the direction of line L, is 1.2, 1.6. Part 2. What is the component of the force F in the direction perpendicular to the line? Vector AF is the component of the force vector OF in the direction perpendicular to the line L. We can also see that vector OA plus vector AF is equal to vector OF. Now vector AF is the component of vector OF perpendicular to the line L, which we've just seen, and vector OA plus vector AF is equal to vector OF. Rearranging this equation to make vector AF the subject, we have vector AF is equal to vector OF minus vector OA. So vector AF is equal to 2, 1 minus 1.2, 1.6. Subtracting the relevant components, 2 minus 1.2 is 0.8, and 1 minus 1.6 is equal to negative 1.6. So vector AF is the column vector 0.8, negative 1.6. Question 12c. The points A and B are fixed points in a plane and have position vectors A and B respectively. The point P with position vector P also lies in the plane and is chosen so that angle APB equals 90 degrees. Part 1. Explain why the dot product of vector A minus vector P and vector B minus vector P equals 0. Here is a diagram that reflects the information in the question. We have 3 points, A, P, and B, and position vectors A, P, and B respectively. Angle APB is 90 degrees. Now vector AP is vector A minus vector P, and vector BP is vector B minus vector P. Now the dot product of vector AP and vector BP is equal to the magnitude of vector AP multiplied by the magnitude of vector BP multiplied by the cosine of angle APB, which equals the magnitude of vector AP multiplied by the magnitude of vector BP multiplied by the cosine of 90 degrees, and cos of 90 degrees of course is 0. Therefore, the dot product of vector A minus vector P and vector B minus vector P is equal to 0. Part 2. Let vector M equal half times the sum of vector A and vector B. Denote the position vector of point M, the midpoint of point A and point B. Using the properties of vectors, show that the magnitude of vector P minus vector M all squared is independent of vector P and find its value. From part 1, the dot product of vector A minus vector P and vector B minus vector P is equal to 0. Expanding the left-hand side, that equals A dot B minus A dot P minus B dot P plus P dot P is equal to 0. We'll call that equation number 1. Now the square of the magnitude of vector P minus vector M is equal to the dot product of vector P minus vector M and vector P minus vector M, where M is equal to half times the sum of vectors A and B. Expanding the right-hand side, that equals to P dot P minus 2 times M dot P plus M dot M. Substituting half times A plus B for M here, here and here, that equals to P dot P minus 2 times half times A plus B dot P plus half times A plus B dot half times A plus B. And that equals to P dot P minus A dot P minus B dot P plus 1/4 times A dot A plus 2 times A dot B plus B dot B. And we'll call that equation number 2. So from equation number 1, rearranging equation number 1, we have P dot P is equal to A dot P plus B dot P minus A dot B. So from equation number 2, the square of the magnitude of vector P minus vector M is equal to A dot P plus B dot P minus A dot B minus A dot P minus B dot P plus 1/4 times A dot A plus half times A dot B plus 1/4 times B dot B. So what's happened here is I've replaced the P dot P from equation 2 with the right-hand side from equation number 1. Simplifying the right-hand side, there is some cancellation, so we have the A dot P and the minus A dot P will cancel, for example. That equals to 1/4 times A dot A minus half times A dot B plus 1/4 times B dot B. Factorising out 1/4, that equals to 1/4 times A dot A minus 2 times A dot B plus B dot B, which equals to 1/4 times A minus B dot A minus B, which is equal to 1/4 times the square of the magnitude of vector A minus vector B, which is independent of P. Now note that 1/4 times the square of the magnitude of vector A minus vector B is equal to 1/4 times the square of the magnitude of vector B minus vector A. Part 3. What does the result in part 2 prove about the point P? Point P moves such that its distance from point M is constant. Now from part 2, the square of the magnitude of vector P minus vector M is equal to 1/4 times the square of the magnitude of vector A minus vector B. Taking the square root of both sides, the magnitude of vector P minus vector M, which represents the distance of point P from point M, is equal to half times the magnitude of vector A minus vector B, and this is a constant. Now a point that moves such that its distance from another fixed reference point describes the path of a circle. And in this case, point P lies on a circle whose diameter is AB, centre M, and radius half times the magnitude of vector A minus vector B. Question 12D. Use mathematical induction to prove that 2 to the power of 3n minus 3 to the power of n is divisible by 5 for n greater than or equal to 1. The first step is to show the statement is true for one value of n. A convenient value to choose is n equals 1. Substituting n equals 1 into the statement, we have 2 to the power of 3 times 1 minus 3 to the power of 1, which equals 8 minus 3, which equals 5, which is divisible by 5. Hence, the statement is true for n equals 1. The next step is to assume the statement is true for n equals k. That is, 2 to the power of 3k minus 3 to the power of k equals 5a, where a is an integer. The next step is to show that the statement is true for n equals k plus 1. So from the left-hand side of the assumption, we're going to substitute k plus 1 for k. So we have 2 to the power of 3 times k plus 1 minus 3 to the power of k plus 1, which equals 2 to the power of 3k plus 3 minus 3 times 3 to the power of k, which equals 8 times 2 to the power of 3k minus 3 times 3 to the power of k, which equals 8 times 5a plus 3 to the power of k minus 3 times 3 to the power of k from the assumption. So I've replaced 2 to the power of 3k with 5a plus 3k by rearranging the assumption. And that equals 40a plus 8 times 3 to the power of k minus 3 times 3 to the power of k, which equals 40a plus 5 times 3 to the power of k after combining the like terms. Factorising out 5, that equals 5 times 8a plus 3 to the power of k, which is divisible by 5. Therefore, by the principle of mathematical induction, the statement is true for all n greater than or equal to 1. Question 13a. Using the substitution x equals sine squared theta or otherwise, evaluate the definite integral from x equals 0 to x equals half of the square root of x over 1 minus x dx. The substitution x equals sine squared theta is a composite function. That is, x equals sine theta all squared. So the chain rule will need to be applied to differentiate x with respect to theta. So dx d theta is equal to 2 sine theta cos theta. Multiplying both sides of the equation by the differential d theta, we have dx is equal to 2 sine theta cos theta d theta. Next, change the limits of integration in terms of theta. When x equals 0, sine squared theta equals 0, and solving for theta, we have theta equals 0. And when x equals half, sine squared theta equals half. Taking the positive square root of both sides, we have sine theta is equal to 1 over the square root of 2. Taking the inverse sine of both sides, we have theta is equal to pi over 4. Next, express the integrand in terms of theta. So the integral becomes the integral from theta equals 0 to theta equals pi over 4 of the square root of sine squared theta over 1 minus sine squared theta times 2 sine theta cos theta d theta. Now 1 minus sine squared theta is equal to cos squared theta using a Pythagorean identity. So the integral becomes the integral from theta equals 0 to theta equals pi over 4 of the square root of sine squared theta over cos squared theta times 2 sine theta cos theta d theta. Now we're taking this square root of squares, so the integral becomes the integral from theta equals 0 to theta equals pi over 4 of sine theta over cos theta times 2 sine theta cos theta d theta. Now there will be some cancellation, so this cos theta will cancel with this cos theta here, and the 2 can be taken outside of the integral. So the integral becomes 2 times the integral from theta equals 0 to theta equals pi over 4 of sine squared theta d theta. Now to integrate sine squared theta, we need to express it in terms of the double angle for cos. Now note that cos 2 theta is equal to 1 minus 2 sine squared theta. And making sine squared theta the subject, we have sine squared theta is equal to half times 1 minus cos 2 theta. So the integral becomes the integral from theta equals 0 to theta equals pi over 4 of 1 minus cos 2 theta d theta, which equals theta minus half times sine 2 theta from theta equals 0 to theta equals pi over 4. And applying the limits of integration, that equals pi over 4 minus half times sine pi over 2 minus 0, which equals pi over 4 minus half. Question 13b. A device playing a signal given by x equals the square root of 2 times sine t plus cos t produces distortion whenever the absolute value of x is greater than or equal to 1.5. For what fraction of the time will the device produce distortion if the signal is played continuously? Express x in terms of r sine t plus alpha, where alpha is an auxiliary angle greater than or equal to 0 and less than or equal to pi over 2. So root 2 sine t plus cos t is equivalent to r sine t plus alpha. Expanding the right hand side, we have root 2 sine t plus cos t is equivalent to r sine t cos alpha plus r sine alpha cos t. Equating coefficients, we have r cos alpha is equal to root 2 and r sine alpha is equal to 1. Forming two equations in r and alpha, we have equation number 1, r cos alpha is equal to root 2, and equation number 2, we have r sine alpha is equal to 1. Solving these two equations simultaneously, since we have two equations with two unknowns, squaring both equations and adding them together, we get r squared cos squared alpha plus r squared sine squared alpha is equal to 3. Factorising out r squared, we get r squared times cos squared alpha plus sine squared alpha is equal to 3. And cos squared alpha plus sine squared alpha is equal to 1. So r squared is equal to 3. Taking the square root of both sides, we get r is equal to the square root of 3. And because r represents an amplitude, it needs to be the positive square root. Taking equation number 2 and dividing it by equation number 1 to solve for alpha, we have r sine alpha divided by r cos alpha is equal to 1 over root 2. And the r's cancel, and sine alpha divided by cos alpha is equal to tan alpha. So tan alpha is equal to 1 over root 2. And taking the inverse tan of both sides, we get alpha is equal to inverse tan of 1 over root 2. So x is equal to root 3 times sine t plus alpha, where alpha is equal to inverse tan of 1 over root 2. The next step is to solve for t, the inequality, the absolute value of root 3 sine t plus alpha greater than or equal to 1.5 or 3 over 2. Dividing both sides of the inequality by root 3 and expressing the absolute value as two separate cases, we have sine t plus alpha is greater than or equal to root 3 over 2, or sine t plus alpha is less than or equal to negative root 3 over 2. Now the value of alpha is unimportant in determining the fraction of time that the signal is distorting. Let theta equal t plus alpha. The period of sine theta is 2 pi. Now the values of theta, where sine theta is equal to plus or minus root 3 over 2, are pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. And we're interested in the fraction of time that the signal is in these two regions. The fraction of time that the absolute value of sine theta is greater than or equal to 1.5, which corresponds to the shaded regions here and here, is equal to 2 pi over 3 minus pi over 3, which is the width of this region, plus 5 pi over 3 minus 4 pi over 3, which is the width of this region, and closing those in brackets, dividing that by 2 pi, we get 2 pi over 3 divided by 2 pi, which equals 1 over 3. Question 13c, Part 1. Prove the trigonometric identity cos 3 theta equals 4 cos cube theta minus 3 cos theta. Cos 3 theta can be expressed as cos 2 theta plus theta, which expands to cos 2 theta times cos theta minus sin 2 theta times sin theta, which equals 2 cos squared theta minus 1 times cos theta minus 2 sine theta cos theta times sine theta. Expanding the brackets, we get 2 cos cubed theta minus cos theta minus 2 sine squared theta cos theta. Now sine squared theta is equal to 1 minus cos squared theta. So this expression becomes 2 cos cubed theta minus cos theta minus 2 cos theta times 1 minus cos squared theta. Expanding the brackets here, the expression becomes 2 cos cubed theta minus cos theta minus 2 cos theta plus 2 cos cubed theta. Collecting the like terms, that equals 4 cos cubed theta minus 3 cos theta. Therefore, cos 3 theta equals 4 cos cubed theta minus 3 cos theta as required. Part 2. Hence find expressions for the exact values of the solutions to the equation 8x cubed minus 6x equals 1. Starting with the polynomial equation 8x cubed minus 6x equals 1, divide all three terms by 2 so we get 4x cubed minus 3x equals half. Now let x equal cos theta. So replacing the x with cos theta, we have 4 cos cubed theta minus 3 cos theta equals half. Now the left-hand side can be replaced with cos 3 theta from part 1. So cos 3 theta equals half. Taking the inverse cos of both sides, we have 3 theta equals inverse cos of half, which equals pi over 3, 5 pi over 3, or 7 pi over 3. Dividing all terms by 3, we get theta is equal to pi over 9, 5 pi over 9, or 7 pi over 9. Now the solutions to 8x cubed minus 6x equals 1 correspond to the roots of the cubic polynomial alpha, beta, and gamma. And that's why there are 3 values of theta. Hence, the 3 solutions to the polynomial equation are x equals cos of pi over 9, cos of 5 pi over 9, or cos of 7 pi over 9. Question 14a, Part 1. Sketch the graph of y equals x cos x for x greater than or equal to negative pi and less than or equal to pi, and hence explain why the integral from x equals negative pi over 2 to pi over 2 of x cos x dx equals 0. Let y equal x cos x. X-intercepts occur at x equals 0 and x equals plus or minus pi over 2, since these are the x values where either the x term or the cos x term in the product equals 0. Now x cos x is greater than 0 in the interval 0, pi over 2, and x cos x is less than 0 in the interval negative pi over 2, 0. Geometrically, the graph of y equals x cos x is an odd function, hence has point symmetry about the origin, and this needs to be shown in the graph. Here is the graph of y equals x cos x. It may help to do a table of values to get a little bit of extra detail in the graph. So it's important to show that it is an odd function and the 3 x-intercepts are shown. Now the integral from x equals negative pi over 2 to x equals pi over 2 of x cos x dx equals 0 because the function is odd and signed area is being considered. Now note, as a general rule, the product of an odd function and an even function is odd. Part 2. Consider the volume of the solid of revolution produced by rotating about the x-axis the shaded region between the graph of y equals x minus cos x, the x-axis, and the lines x equals negative pi over 2 and x equals pi over 2. Using the results of part 1, or otherwise, find the volume of the solid. Since the volume of the solid of revolution is produced by rotating the curve about the x-axis, the formula for the volume is given by v equals pi times the integral of y squared dx, which equals pi times the integral from x equals negative pi over 2 to x equals pi over 2 of x minus cos x all squared dx. Expanding the brackets, we get pi times the integral of x squared minus 2x cos x plus cos squared x dx, which equals pi times the integral of x squared plus cos squared x dx, since the integral from x equals negative pi over 2 to x equals pi over 2 of x cos x dx equals 0 from part 1. And this equals pi times the integral from x equals negative pi over 2 to x equals pi over 2 of x squared plus half times cos 2x plus 1 dx. Which equals pi times x cubed over 3 plus 1 over 4 times sine 2x plus x over 2 from x equals negative pi over 2 to x equals pi over 2. Applying the limits of integration, that equals pi times pi cubed over 24 plus 1/4 sine pi plus pi over 4 minus negative pi cubed over 24 plus 1/4 sine negative pi minus pi over 4. Which simplifies to pi times pi cubed over 12 plus pi over 2. And factorising out 1 over 12, we get pi over 12 times pi cubed plus 6 pi cubic units. Question 14b. The population of foxes on an island is modelled by the logistic equation dy dt equals y times 1 minus y, where y is the fraction of the island's carrying capacity reached after t years. At time t equals 0, the population of foxes is estimated to be 1/4 of the island's carrying capacity. Part 1. Use the substitution y equals 1 over 1 minus w to transform the logistic equation to dw dt equals negative w. Expressing y in terms of w using a negative index, y is equal to 1 minus w to the power of negative 1. Now by the chain rule, dy dw is equal to negative 1 minus w to the power of negative 2 multiplied by the derivative of 1 minus w, which is negative 1, and that equals 1 over 1 minus w all squared. Now dw dy is the reciprocal of dy dw, and that equals 1 minus w all squared. Now we're going to treat this as a related rate of change. That is, dw dt is equal to dw dy times dy dt. And that equals 1 minus w all squared times y times 1 minus y, where y is equal to 1 over 1 minus w. Substituting 1 over 1 minus w for y, dw dt is equal to 1 minus w all squared times 1 over 1 minus w times 1 minus 1 over 1 minus w. Combining these two terms together, that equals 1 minus w all squared times 1 over 1 minus w times negative w over 1 minus w. Multiplying all three terms together, that equals negative w times 1 minus w all squared over 1 minus w all squared. So this term will cancel with this term, so we get negative w. Therefore, dw dt is equal to negative w as required. Part 2. Using the solution of dw dt equals negative w, find the solution of the logistic equation for y satisfying the initial conditions. Apply separation of variables to the differential equation dw dt equals negative w. Multiply both sides by the differential dt and divide both sides by w to obtain dw over w equals negative dt. Integrating both sides, we obtain ln of the absolute value of w equals negative t plus c. Applying the initial conditions to find the constant of integration c, when t equals 0, y equals 1 over 4. Hence, 1 over 4 is equal to 1 over 1 minus w, which gives a value of w of negative 3. Therefore, the constant of integration c is equal to ln of the absolute value of negative 3. So the equation becomes ln of the absolute value of w is equal to negative t plus ln of the absolute value of negative 3. Raising both sides of the equation to base e, we get w equals e to the power of negative t plus ln of the absolute value of negative 3. Simplifying the right-hand side, we get w equals negative 3 times e to the power of negative t. Now y is equal to 1 over 1 minus w. So substituting negative 3 times e to the power of negative t for w, we get y is equal to 1 over 1 plus 3 times e to the power of negative t. Part 3. How long will it take for the fox population to reach 3/4 of the island's carrying capacity? Solve for t the equation 3 over 4 equals 1 over 1 plus 3 times e to the power of negative t. By cross multiplication, the equation becomes 3 times 1 plus 3e to the power of negative t equals 4. Dividing both sides by 3, we get 1 plus 3 times e to the power of negative t is equal to 4 over 3. Subtracting 1 from both sides of the equation, we get 3 times e to the power of negative t is equal to 4 over 3 minus 1. Dividing both sides by 3, we get e to the power of negative t is equal to 1 over 3 times 4 over 3 minus 1. Taking the natural logarithm of both sides, we get ln of e to the power of negative t is equal to ln of 1 over 3 times 4 over 3 minus 1, which becomes negative t equals ln of 1 over 3 times 4 over 3 minus 1. Multiplying both sides by negative 1, we get t is equal to negative ln of 1 over 3 times 4 over 3 minus 1, which equals negative ln of 1 over 9, which equals ln of 9, which is approximately 2.2 years, correct to 1 decimal place. Question 14c. The diagram below is a sketch of the graph of the function y equals f of x. Part 1. Sketch the graph of y equals 1 over the absolute value of f of x. Your sketch should show any asymptotes and intercepts, together with the location of the points corresponding to the labelled points on the original sketch. Create a table of values that contain the x and y coordinates of the 5 points on the original graph. That is 0, 7.5, 0.5, 2.5, 1, 0, 2, negative 1.75, and 3, 0. The third row is found by taking the absolute value of f of x and then finding the reciprocal. Now note that where x equals 1 and x equals 3, f of x is equal to 0, and the reciprocal of 0 is undefined, so that's where the vertical asymptotes will be. The absolute value of 7.5 is 7.5 and its reciprocal is 0.13. The absolute value of 2.5 is 2.5 and its reciprocal is 0.4. The absolute value of negative 1.75 is positive 1.75 and its reciprocal is 0.57. Here is a sketch of the graph of y equals 1 over the absolute value of f of x, showing the 3 points that we found in our table of values and the 2 vertical asymptotes. Part 2. How many solutions does the equation 1 over the absolute value of f of x equals x have? Sketch the graph of y equals x on top of the graph sketched in part 1 and look for points of intersection. The points of intersection of the graphs of y equals x and y equals 1 over the absolute value of f of x represent solutions to the equation 1 over the absolute value of f of x equals x, and they're shown in red on the graph. So from the graph, there are 5 solutions evident.